The next topic that we're going to learn is inheritance in Java. So basically, we have looked into inheritance in C++. We basically used to give a class, derived class, colon, public, the base class. So with that statement in C++, we could have conveyed the meaning that there is inheritance involved between the derived class and the base class. So similarly in Java, when we talk about inheritance, we are going to identify it with a different keyword. So here the keyword under concern is extends, not this word, extends. So extends is a keyword indicating the properties of the superclass name to be extended or inherited to the derived class name. So what we give is like you have a class name, extends superclass name. You don't need the brackets to be used, otherwise also it's fine. So inside that class you will declare the field as well as methods, and all the concepts are similar to what we had looked in C++. Now if we look at this graph over here, the properties of inheritance are same in C++ or Java. So basically you can see that you have a single inheritance over here, multi-level inheritance, hierarchical inheritance, and multiple inheritance. The concept is applicable in a different way. So primarily this concept will be explained later, but our focus right now will be on single, multi-level and hierarchical inheritance, and multiple will be explained later. So like as mentioned before, inheritance can be defined as a process where one class acquires the properties, that is the methods as well as fields of the other class. And like the superclass and the base class and derived class concept, here we have superclass and subclass. And here the keyword used is extend. So we'll look at a program over here. So we have a class called calculation, and we have a keyword called, a variable called z. We have functions defined over here. You can see that there is a function called addition, which will receive two arguments x and y, and you will display the result, computed result z as a statement. Sum of the given numbers is plus z. And you have a function called subtraction, which will display the difference between the values. And these are the contents of the class called calculation. So the variable z is declared over here, and the x and y variables are declared here. And you have another class here, my calculation, which is extending from the base class or the super class called calculation. You have another function here called multiplication, where you have another two sets of arguments x and y, and you'll be getting the product, and the product of the given numbers is z. The result will be added. Now this plus, please don't take it as addition. It is representing the addition or concatenation of another string, resulting in a statement to be given, like the product of the numbers is the result. And you have the main function. So I'm passing my values over here to a and b variables. Int a is declared as 20 and int b is declared as 10. So I'm creating my object which belongs to the derived class. So hope you remember that when we did the programs in C++ also, the objects, they belong to the derived class, and it was a derived class objects that call the functions from the base class. So here also it's the same. Your derived class is my calculation, and the object demo is of that particular class, and you are creating that object demo over here, and demo is able to call addition from the superclass, subtraction from the superclass, as well as multiplication from its own class. So this is the concept of inheritance, and we'll run this program and show the output. So the process is brought down over here, the program is brought down over here, and we're going to run it, execute, and we can see that the result has come 20. Sorry, the sum is 30, the difference is 10, and the product will be 200 when the numbers given are 20 and 10. I make a small change over here. I make it 10. I make this 5. So sum should be 15, difference should be 5, and multiplication should be 50. 15, 5, and 50. So I hope the concept of inheritance is clear. The main point to be understood is a keyword called extends, and the rest of the concepts are same as like what we had mentioned over in the previous concepts of C++. The object should belong to the derived class, and by this way the inheritance has been displayed over here. Now, this particular scheme in this particular program, the type of inheritance shown is single inheritance, because there are only two classes involved. You have a class A and class B, and class B inherits from class A. So it can be treated as a single inheritance scheme. So if you look at this diagram, a single inheritance scheme will be like this: A and B over here, B inheriting from A. Multi-level inheritance will be inheriting from the object can be from B or it can be from C. B can inherit from A and C will inherit from B as well as A. Hierarchical inheritance, A will be in this form over here. B and C inherits from A. Now B and C are not connected. B can inherit from A as well as C can inherit from A. And multiple inheritance we are not dealing right now. It will be dealt as a separate topic. So we'll take a look at this program. Another case of a single inheritance over here, a class called teacher. You have a string designation, you have a college AJC, and it has a function called does, and it will be displaying a word called teaching. You have a subject called or a class called math teacher, which is extending to teacher. And then you have this main subject variable initialized with maths, and then you have in the main function you're creating an object of the derived class, that is a math teacher obj, and you'll be displaying this obj.college, which should be AJC, obj.designation, which will be teacher, and obj.main subject, which will be maths, and obj does is being called obj function. Here all these are variables, and here it calls a function, so it should be displaying the value called teaching. So we'll run this program and see. This is the program, and we'll execute it. As mentioned, the college name AJC, designation teacher, main subject maths, and object.des is displaying this teaching value or string. Now this is also an example of single inheritance. You have a class 1 over here. Class 2 will be extending to 1, and then it will be displaying Amal as well as Jyoti. So you have the derived class 2 over here. So derived class will be having its object G. G is calling the function print1, and G is calling the function print2. Again, this will be an example of single inheritance. And when we run this particular program, you can see that it will display the strings Amal followed by Jyoti. So that is an example of your single inheritance. Now when we come out multiple inheritance, I hope you can remember this diagram. In multiple inheritance, there will be more than two classes. So B inheriting from A and C inheriting from B. So when we look at it, example of multiple inheritance, we can see that you're having an object, a class called 1 over here, which is a superclass, and it will be displaying this string called Amal. You're having class 2 over here, which is extending to 1, and it will display Jyoti, and it will be extended, or you have another class 3 which is extending to 2, and it will display College of Engineering. Now we have the main function. The object G belongs to the base derived class 3, and it is able to access print1, print2, and print3, which means it is supporting multiple inheritance. Otherwise, if this particular class 2 was not having extend statements, this would not have worked out. So I'll just run this program and show. So when we try executing it, it displays Amal, Jyoti, and College of Engineering. Basically, the object of the derived class G, which belongs to class 3, is calling the function print1, print2, and print3. If I remove this keyword extends 1, this program would have led to an error, because when we remove that keyword extends, it doesn't support multiple inheritance. So you have to write it as extends 1, and then you run it again, and you can see that it's displaying. So that was multiple inheritance. And now about the hierarchical inheritance. If you look at the same concept, I have class 1 over here, and I have class 2 which extends to 1, and class 3 which extends to 1. So basically it supports hierarchical. You have a class A, class B extending to A, and class C extending to A. So B and C does not have any relationship between each other. So this is the class 1, 2 extends to 1, and 3 extends to 1. So there is no connection between 2 and 3. So it displays Amal Jyoti College of Engineering to fostering excellence in engineering education based on self-financing engineering colleges in Canada. And you are creating two objects. So like you look at this block diagram, you can see that there are two derived classes, B and C. So here there will be two classes, 2 and 3. So we are creating an object G and H, and H will be calling print underscore 1 of 1 and print underscore 2 of 2, and object 3 H of class 3 will be calling print underscore 1 and print underscore 3. So you can see that when we run this particular program, when we execute it, the object G is calling print underscore 1, Amal Jyoti College of Engineering, and print underscore 2 is fostering excellence in engineering education. And H is calling print underscore 1, again Amal Jyoti College of Engineering, and print underscore 3, which is best among self-financing engineering colleges in Kerala. So when I write it as print underscore 2, it will not work, and it will result in an error, because print underscore 2 is a function that does not exist in any way that can be accessed by the object of class 3. So I hope that concept is clear regarding the three kinds of inheritance that we have spoken about. We spoke about single inheritance, we spoke about multi-level inheritance, and we spoke about hierarchical inheritance.